Okay, so we're going to look at how we sketch the graph of absolute value functions, where we've got like really it's a composition of functions. We have a function, and then we're just taking its absolute value. And so we want to see what that does to the graph. Now just keep in mind that, just as an example, when you take the absolute value of, negative 4, we all know that that answer is 4, and the absolute value of 5 is 5. So when you take the absolute value of negative numbers, the result is a positive number. And that's really because absolute value, by definition, is described as a distance from 0. So negative 4 is 4 units away from 0. Its absolute value is 4. Let's see what that means. What does it mean to take the absolute value of a graph like x minus 3 times x plus 4? Well, let's do this. Let's focus on what x minus 3 times x plus 4 is. So that is a function, and its zeros, it's in factored form. Its zeros are negative 3, and, positive 3 and negative 4. Positive 3 and negative 4. Okay, now it's a parabola, and how do I know it's a parabola? Well, if I were to multiply this out, I'd get an x squared term, right? And that would be the highest power. So I know it's a parabola, and when I multiply those, I get x squared, so it's opening up. So, it would be, I'm just going to sketch briefly what the picture would look like. Don't sketch this yet, because this is not what we're going to graph. Okay, so that's the graph of x minus 3 times x plus 4. Let's see what happens when I put that in the calculator, but with an absolute value around it. So where's the absolute value function? Go to second. Just go to math, not second, just math. Go to number, ABS, and we're going to put in x minus 3 times x plus 4. And just see if our window, maybe we'll make the standard window negative 10 to 10 in the x and the y direction. See what that does. Looks like we're kind of missing the top, so I'm going to go up a little higher. There we go. So one thing to notice is first of all, there's no negative values. And that's because when you take the absolute value of a function, it takes all the negative answers and just makes them positive. So like the parabola was down here in between negative 4 and 3, but when you take the absolute value, all the negative values become positive. So if we were to sketch the absolute value of this function, all the positive values stay positive, but all the negative ones become positive as well. And so this is really the graph. So graphically, that's what taking the absolute value does. It takes all negative values and just basically flips them over the x-axis. So what does that mean about this? We can put this in the calculator, but we could also figure it out because we can graph cosine, and all we need to do to get a graph of the absolute value of cosine is to do this. Let's get our standard intervals. Let's get our standard intervals, and cosine, goes up to 1 and down to negative 1. So this is the cosine graph normally. So I'll sketch. No, I wouldn't sketch this yet, or if you're going to do it, sketch it very lightly. right? That's the normal cosine graph. But what we really want is all the negative values to become positive because we're taking the absolute value. So we're really going to graph this, but we're not going to go down. It's going to come up, and this is going to come up. It's not the most beautiful sketch, but you get the idea. So all, like, very lightly, I'll put where the negative, where those values were. They were down here. Oops. Right, the graph really was doing this. Right, it was doing this, going down, but all the negative values are now positive. So it's the red that's the graph of this. And there are a few. There's some interesting questions you can ask. First of all, what's the period? What's the period of the absolute value of cosine? Well, remember the period is the length of one cycle. So all we need to do is figure out how long it takes this picture to repeat. So like if I start here and go down, when does this, when do I get to another peak again? Right here at pi. So the period of that graph is just pi. Alright, so it had the effect of changing the period. It also had the effect of changing the range, right? Because the lowest values for cosine used to be -1, now they're up at 1. So so our range, I'm sorry, the lowest points used to be at -1, now the lowest points are 0. So our range is now just 0 to 1. Okay. Well, then how would we handle this? Absolute value of cosine x minus 3. Well, it's just this picture shifted down 3. So that shouldn't be too hard to sketch. Let's call that -3. And I can get my intervals going again, and I'm going to make that's -2 and that's -1. So all I'm going to do is I'm going to take this picture and shift it down 1. So all my points here, like the point was 0, 1, I got to move that down 3, right? So that means it's going to go down 1 to 0, then 1 to -1. My scale's a little different than this, but you get the idea. Down 1 to 0, down 2 to -1, and then down 1 more to -2. So that would be where that peak is now down here. And all of the zeros here, right, all these are going to move down 3, so they're all going to be right here on the horizontal line, y equals 3. So at pi over 2, it's going to be down here at 3. 3 pi over 2, it's going to be down here. So all the ones are now at -2. So I'm just going to try to translate all the points downwards. And so this is my resulting shifted, appropriately labeled absolute value of cosine x minus 3. Notice the period is still pi, right? That's the length of one cycle. That didn't change. My range now would be, my lowest output values are -3. And the highest they can be is -2. Alright, so that's a good, just a good overview of how absolute values affect graphs. Okay, makes them more positive. And then we just threw in a little transformation bonus to kind of look at. Okay, so you can use a calculator to sort of understand these, but if you're expected to graph them, make sure you can do them without a calculator so that I can see the reasoning, the intervals appropriately written, things like that.